Hello everybody. Welcome to the second stream of Hacking Hubs. I'm your host Greg Fodor. Just waiting for the clock to hit 4 here so we can start. So today we are going to be going over some more operation oriented stuff. I put up a little Twitter poll to see what people were interested in, and it turned out it was an even split, so I had to decide myself. And so today I'm going to try to cover a couple more kind of networking related things that may be interesting for anybody who's coming at this from an operations background or looking to understand a bit more about how Hubs works under the hood with regards to networking. And hopefully we'll actually fix some problems live on the stream, which will be fun. Okay, cool. So it's 4 o'clock. I'm going to dive right into it. So the first thing we're going to look at today is one of the things that has led to what we think to be the root cause of a number of connectivity issues we've been having in Hubs. And so, you know, as we've pushed the software out over the last several months, we've, you know, had a variety of different things that people have run into that prevented them from connecting to the site. And 9 times out of 10, the reason that this happens is because of connectivity issues with a protocol that, or some software that we use in the browser called WebRTC. And so what WebRTC does is, I'll make some notes here. So today we're going to be talking a little bit about WebRTC. Both of the things I'm going to be going over are related to WebRTC. And so what WebRTC is it's a in-browser networking stack that enables voice, video, and unreliable and data transmission between browsers connected to one another. And so typically you would use something like WebRTC for things like video conferencing or audio calls or even network games. And so in fact, what we use it for is primarily for sending the audio between people in Hubs. And we also use it when you share your screen or when you are sharing your video camera from your computer. And so typically when people are using WebRTC, they do what is called peer-to-peer networking. And that is typically abbreviated P2P. And when you're doing that, what's going on is your browser is actually trying to directly connect to the other person's computer through the internet without any centralized server per se. It still may go through different routers and switches along the way, but there's no actual server facilitating the communication. And so it's actually a very nice way to have direct high bandwidth communication with another person. However, for Hubs, when we want to send the audio to people, we don't want to do it that way because if you are using a situation where you have peer-to-peer connectivity between users, that means if you have, say, 10 people in a room, you're going to send your audio data to those 10 people separately because you connect directly to them through the internet. And so for Hubs, we actually do not do peer-to-peer networking for audio or for video sharing. We use what's called a select forwarding unit, which is a fancy name for a central server. And so this is a centralized server that will receive messages from people like audio or video and forwards it, hence the name SFU, to others who are subscribed. And this is a really common pattern that you would use if you're going to try to get a lot of people connected through WebRTC to one another, because when you use a centralized server, in fact, I'm going to even try using my fancy new drawing tool here. So if you're connected to people in a peer-to-peer situation, you'll be kind of all across the internet here, and you'll be running your web browser. Let's see if these drawings coming up. Nope. Oh, too bad. Guess not. All right, operations fail number 1. Well, anyway, back to this. So anyhow, if you're using a SFU centralized server, then what it means is that the bandwidth that each user was going to have to use in terms of what they send will just be sent single up to the server, a single connection. And so that, oh, here we go. Let's see if this is working now. Yes, yes. Nope, never mind. Okay, so I'll give up on that for the next time. And so we use an SFU for our communication, which is a central server we run. Specifically, we run a server called Janus, Janus Gateway, which is one of several open source SFUs you can use. And it's Janus Gateway. And so, so that's kind of the current situation. And so one of the things that we've been having is various people have been having problems to connect to our WebRTC server. And so there's really two problems that I'll be talking about today that we've tracked down and have addressed in various ways. So the first thing that we've seen is that people were getting connectivity problems because when they were sending the messages to the server, the responses weren't coming back, and it's a bit strange because these the messages do come back for the first couple, but then eventually they stop. And so, in fact, I don't actually really have a great working theory of the real kind of root cause of this. But fortunately, because everyone is out on the internet kicking the tires on this, we actually have several now good leads that this is due to a firewall issue in which we're inadvertently blocking what are called ICMP packets. And so I'm going to basically go ahead live on the stream and try to address this in our hubs.mozilla.com service. And we've already actually rolled this improvement out to the Hubs Cloud servers for those who have, or sorry, I should correct that. We haven't released that yet, but it's in submission with AWS. And so subsequently, people that create stacks after the update will get this. But I'm going to actually go ahead and implement this now for our hubs.mozilla.com stack. So let me kind of illustrate what we're going to try to do. So I'm logged in here to our AWS console, and this is the central console for managing all of hubs.mozilla.com's operations. And so I'll switch to the region that our servers are in, which is in California. And really the root thing that we're going to try to change today is update our firewall rules for our servers, specifically our servers that are running this Janus WebRTC SFU I mentioned, to support incoming traffic that is of the form of ICMP packets. And so, so if I go to EC2, you'll be able to see the Hubs infrastructure, which maybe is a nice peek behind the curtain. And you can see these are the servers we're running here. So we're running quite a bit number of servers because we run two clusters, a dev cluster and a production cluster. And then those have a lot of redundancy in them as well. So we actually do what you call blue-green deploys in our software. So we actually have servers that are offline, but still connected to everything else, but are not serving any production traffic. And then we have servers that are online that are receiving traffic. And then what we do is when I wish I could draw this on my iPad. If we deploy code, what we do is we first push it to the dark cluster, the dark servers, I should say, and then we test it. So in that case, we're testing it on the server that is set up exactly how it's going to be when it's live. So there's no other variables that could be involved if it were to break. And if it works on that server, and we manually test it, we go in, we run Hubs, we play around with it. Once it looks good, we just flip a switch, and then that server becomes the one that the public internet is going to see. And then the other servers that used to be there are now the dark ones for the next deploy. And so that's why we have so many servers here. So we have both a dark and non-dark subset of servers in production, and we have a dark and non-dark subset of servers in what we call our dev infrastructure. And so our dev infrastructure sits separate from our production infrastructure. And our dev infrastructure is what you use, for example, when you're running your own little Hubs client on your computer and you're testing your own little idea out. It's actually going to be connecting to these dev servers to do that communication. So this way you're kind of not going to necessarily be able to affect the stuff that's going on hubs.mozilla.com. So that's kind of that's a high level overview of why we have so many servers. And so you can see here that we have this host type. And so the servers that we're going to be talking about today are the Janus hosts. And these are the ones that are running the Janus SFU I mentioned. So if I go into one of these, you can see that there's a whole lot of information here. And the one that we're most interested in is these security groups. And on Amazon, security groups are basically groups you can assign servers to. They can belong to more than one. And those define basically what ports and what firewall rules are associated with that server, such that users trying to access that server through the internet or through any kind of networking for that matter will have enforced rules that will prevent certain kinds of connectivity from happening or enable it to happen. So if we look at the inbound rules, oops, let's see if this will work on my stream here. Yeah, so there's a lot of ports we open, and these are all strictly necessary. As a general rule of thumb, you don't want to open up ports you don't need to open, because every port that you open is a potential security risk if there were to be a service listening on it, and for other reasons as well. And so, so we have a few ports open, and then it's not just that these are open to the whole internet. So a lot of these are open only to other servers on our infrastructure. So these ports are used for intra-server communication around configuration and understanding what services are actually available for the service to operate. And so you can see these are only targeting internal resources because the source that can talk to this server, these servers with this over this port are a security group, not an IP block. And if it's an IP block, that assumes that we're talking about a network-related connectivity through some IP addressing. So we have SSH access is only, that's port 22, that's only accessible internally because we don't allow SSHing into our servers from the internet directly. And then 7000 is an internal port used for the Janus administrative API that is used to understand how many users are currently connected to this box on Janus. And that's used internally for analysis and reporting and things like that. But now the more interesting ones are the internet open ports. And so we open up port 80 on UDP, we open up port 80 on TCP, we open up 8443 on TCP, and then we also open up this large block on TCP, and then we also open up 443 on TCP as well. Oh, and this large block on UDP. And so these ports all are about talking over WebRTC. And so the 8443 one is there so that you can communicate with the Janus WebSocket server, which is used to coordinate what they call signaling, and it allows you to actually set up WebRTC. If this wasn't open, you wouldn't be able to get to the point where you could even start to talk WebRTC with the server. This doesn't speak WebRTC over this port, it's just a standard WebSocket connection, and then that's used to bootstrap WebRTC from there in a process called signaling, like I mentioned. And then 80 and 443, you might recognize, these are ports used typically for HTTP and HTTPS. However, we're kind of abusing them in this case because they are not used in this context for HTTP and HTTPS. They're used for connecting to what's called turn, and I'll talk more about that later if we get to it. But this is basically a fallback that is used if you're on a firewall. Say you work at a big corporate company or a school or something like that, where they have very strict rules around what ports you can access through the internet. These ports almost always are open because in order to access the web, you would need 443 and 80 to be available for you to connect to over. And so by abusing these ports in a certain sense and using them as a potential connectivity route for WebRTC, it's a fallback mechanism we can use to bypass firewalls that people are working behind that may be problematic for connecting. And so we'll talk more about turn later, maybe in this stream or in another one, but that's what these ports are exposed for, this 80 and this 443. However, you notice we have these large blocks of ports open as well. And so these ports are the ones that you will connect to when you are doing, yeah, for Bob, that's a good question. I assume that there certainly are cases where there's routers that do packet inspection. It's a bit of an open question to me which one is better to use, the kind of standard turn port or abusing ports like this. And so I'm definitely open to understanding more if there are any WebRTC experts out there that can help us understand if that's the preferred or least likely to hit problems route. I've read I think both accounts on the web searching, but that's what we're doing today. Now note that these are going to be TLS encrypted packets, so there'll be some limited ability to read them. And then also on the UDP port, they'll be DTLS encrypted as well. So even the UDP protocol in WebRTC is encrypted when talking to turn as well. And so, packet inspection would start and end with kind of the IP packet headers, not really the actual underlying data. And so these large ports, blocks of ports, are the primary ports that you would like to try to connect over to UDP. These are the ones that you'll directly be speaking to the WebRTC server itself and not hopping through a turn server. And so the ideal scenario is you're going to be connecting over UDP, since that's going to provide the best quality of service for WebRTC. However, Janus also supports TCP as a connectivity route, and this is less desirable, but it'll also be something that will work. The reason that you would prefer UDP is UDP does not introduce any kind of overhead or congestion management. The particular problem that can happen with TCP, which in most cases is a feature, not a bug, is that TCP guarantees that messages will arrive in the order that they're sent. And so if you're talking about sending a phone call through the internet, if you're going to try to guarantee that packets order arrive in the order they're sent, TCP often can kind of stall and have to resend messages or wait for another message to arrive before resuming. And so when you're talking about a phone call or any kind of situation where you don't really care about if you miss something, the phone call is definitely an example of that, because if you're saying something, if a little packet gets dropped, you're not going to really notice, or you will, and it will just be over and you won't worry about it. But if you're in a TCP connection, the whole thing may just wait and get stuck until it gets played back. And so that's why when you would like to use UDP, because UDP will kind of just blow past it. If there's an error or something that went wrong, it'll effectively just get skipped, but it won't get in the way of anything else happening. And before you know it, you'll be on to the next packet and it'll just pick up where it left off. So the ideal scenario when connecting to WebRTC is going to be to use these UDP ports, but they are a large range. And the reason they have to be a large range is because the WebRTC server right now, the way it works is it binds people connected to it on the port. So now there are other techniques that may be possible eventually where you wouldn't have to have this many ports exposed, but that's the way it works now. And so it means that you have to have this range, and since there's a large range there's quite a good chance that you're going to run into firewall issues unless your firewall is completely happy with you connecting both over all those ports and then beyond that over UDP, which is also sometimes not allowed in firewalls. But the good news is that, like I mentioned, we have this TCP 443 and this TCP 80 option there, and so ultimately those will be connected to if you need to connect to them. I should actually correct. I think one of these ports is actually used for WebRTC. One of them is not, but nonetheless, the main thrust of what I was saying is correct. These ports are used as the ultimate fallback for turn, and so they'll get past most firewalls is the assumption. So to pop off the stack, what are we really in here to do? Well, the thing we discovered is that we need to be able to actually whitelist what are called ICMP packets. And these are neither UDP nor TCP. These are packets that are used by just general internet tooling to understand the kind of transport layer of the network. And so, so whenever you say run a command like ping, which I'll show you really quick, let's go here. So if I say ping yahoo.com, because I'm old school, basically these are showing that I have a route to actually talk to yahoo.com. And the ping protocol is a very simple ICMP message type that if a server receives it, it will typically send a reply message, and it's used to determine the round trip time as well as the availability of the host. And so generally it's a good way to test your internet connection that is very, very kind of high level. So if you're trying to determine if you just have basic connectivity to the internet, that's a good way to do it. The only real way that you wouldn't see that work is if your firewall is blocking ICMP, which is, I think, fairly uncommon. However, in our case, we are blocking ICMP because it's off by default. And so what we found out was that there are multiple people in our Discord who were clever enough to actually, I think some person did it through process of elimination. Somebody may have done it because they actually just thought it was the right thing to do. But they discovered that in some scenarios, some of their users couldn't connect to their server. until they allowed inbound ICMP packets to the Janus host. Now, I don't actually know why this would affect things. In fact, the folks on our Discord who are WebRTC experts also, I think, similarly weren't quite sure what could be the root cause. But nonetheless, when it comes to this kind of thing, I'm happy to cargo cult it as long as I can't think of any reason why it's a bad idea. And so that's what we're going to do just now. And so the idea here is we want to add the rule necessary to allow ICMP packets to come inside of our infrastructure here. Now you might think, okay, well, all you got to do is just go in here, click this, do that drop down, click that button, and then just hit go. But that would be a bad idea, because one of the most important things you can do if you're operating a service like hubs.mozilla.com is you want to capture all these kinds of operational changes in code. You don't want to be looking around with your console here. That's great if you're just kind of getting started, but very quickly you'll find that if you're doing that, you really lose track of how things are set up. It becomes very hard to manage, especially if you're trying to have multiple people work on it at the same time. And so most operations that are done with AWS for any kind of non-trivial setup are done through infrastructure automation tools. And the one we use is called Terraform. And so I'm going to show you a little bit about how you go about adding this rule to Terraform. And then the idea is that once you update the Terraform script, it will you run it, and then it will apply the change to the running infrastructure. And so so what I'm going to be doing is I'm going to be going into our Hubs Ops repo. And so our Hubs Ops repo is public source code under the NPL. And this actually contains, I mean, for the most of the life of the project, this was here. It's kind of a DIY set of operational tools that are the exact tools we use, as you'll see, to operate our live service at Mozilla. Now, since the launch of Hubs Cloud, a lot of this is no longer needed for your average person, because we've gone ahead and automated it on AWS Marketplace and now an alpha of DigitalOcean. And so most of these things are no longer needed for anyone that wants to just get up and running. But it can be helpful to see how we do it if you are someone that is looking to stand it up on your own infrastructure in your own way. And this is a good place to start if you have an operations background to do so. Okay, so in our repo, we have a Terraform folder, and this is where we keep all of the stuff that is related to AWS resources that we provision, and it's captured in the form of oh yeah, so the question is this the same Terraform we use for DigitalOcean and AWS? In fact, we don't use Terraform for Hubs Cloud at all. We use different tools for automating the infrastructure on those platforms. So on AWS, we use CloudFormation, which is basically AWS's equivalent of Terraform. And then on DigitalOcean, we actually wrote a program to do this, a little node program called Arbortect that basically takes on the role of setting up all the relevant resources on DigitalOcean for your server. And so that actually is in our Hubs Ops repo as well. If you go to Arbortect, this is a little script that right now it's very specific for DigitalOcean, but this effectively does the same thing as these Terraform scripts or the CloudFormation scripts for Hubs Cloud, and manages your firewall, manages your database, like gets all that up and running so that your server will work. And by the way, the CloudFormation for Hubs Cloud is in the CloudFormation folder in here. So shield your eyes, but this stack.yaml basically encapsulates everything that there is to know about how Hubs Cloud is set up on AWS. And it's a quick read, just print it out, put it in your bathroom maybe, just somewhere where you want to have a good, nice long thing to read. It's only about 4,000 lines of YAML, so it's also a great YAML tutorial. Also makes a great paperweight or other things like that. But that's basically everything in here is this CloudFormation stuff. But like I said, we're going to be focused on Terraform today. So if we go into Terraform, I have it in my editor, so I'll switch back to that. And what we want to do is we want to go to there's a Terraform definition that basically describes the infrastructure for the Janus nodes specifically. So the way we've broken up the Terraform is by these kind of different kinds of servers we run. And so here's the Terraform for the Janus servers. And so this is where our firewall rules live. You can see they're right at the top here. So this is the AWS security group for Janus. These are the definitions. And this is just a text file on my computer, so this isn't reflecting anything in a live system. But the idea here is that by editing this file, we can use Terraform to say, hey, Terraform, take this file and make it so, right? And point to our AWS infrastructure, and then it goes out, it looks at the AWS infrastructure and is like, okay, well, the file says this rule is here and this rule is here, and that's on Amazon too, so that's cool. But then this rule is in the file, but it's not on Amazon. What's up with that? And so then it says, okay, well, there's this new rule you have in your file that you really said it's in the file, but it's not on Amazon. Do you want me to add it? And then you say yes or no, and it'll add it. And the next time you run it, it'll know that it's the same. And so that's a good way to do things. That's called, the fancy word for that is idempotency. It means if you run the same thing over and over again, the net effect will be the same. And if you run it and there's no changes to be made, it'll have no side effects. And so we're going to go in here and we're going to look for a place to stick our ICMP ingress rules. So you can see they're kind of they're ingress and egress. So ingress is a fancy word for inbound rules, things that people can access your server through. And egress is a fancy word for outbound rules, where that's the ports that this server actually has the permission to connect to other servers on. So for example, if you want the server to be able to talk to a web server, like make an HTTP request, you would need an egress rule in that case over port 80. Cool. And so so the first thing you typically do is, so as you can see, Terraform is kind of this pseudo JSON-y type form, but it's not. It's its own little language they have by HashiCorp. And so usually there's a lot of Googling involved in my experience for Terraform. And so I kind of went ahead and found the right document here. And so they do a very good job of documentation. So you can see this is kind of a good example of, they give you a nice example of the key things you may want to configure for a security group. And in this case, it's, oh, interesting. That's a good point. That's a very good point in terms of how it's also used elsewhere. And so you can see they give you an example here, but, oh, and interestingly enough, I think this egress rule may be an ICMP one. Is that right? We don't really need the egress one though. We don't really care to ping. Let's see. So if I go to egress, you can see, let's see. Right, so here's the ingress block, and these are the things that it supports. And so it's kind of nice to just leave a comment. So I just will whitelist all ICMP packets. And so the protocol in this case is ICMP. Oops, I'm sorry, I gotta switch back. So the protocol in this case is ICMP. I just added this new block here, so this is now the new one. And now one of the things that's a little bit hacky that I've seen also in CloudFormation is ICMP doesn't have ports. And you might be scratching your head, like, what does that mean? Well, as I mentioned, ICMP is actually a totally distinct internet protocol. It sits below IP. So like when you hear like TCP IP, IP is the top part of that protocol. But this is actually a protocol that sits outside, alongside TCP and alongside UDP. And so in that sense, TCP and UDP are actually, I don't want to say the wrong thing. Maybe I might be even saying the wrong thing. I think that the ports, I'm going to look this up live. Okay, so basically it's just like, so let's do that. Look at the IP packet frame. I should know this offhand, but it's a little embarrassing. I don't. So I go here. Right. Okay. So perhaps I didn't misspeak, thankfully, but the let's see. Oh yeah. So it looks like to me that the ports are actually not part of IP, which makes some sense to me. Let me just take a look here really quick. Okay, let's see. Some people in the audience may be just scratching their heads while I look at this, but it's always good to try to understand. Okay, so basically the, yeah, so the ports are not part of this IP, of the IP layer. And so the ports are kind of a concept, not an IP, if I am understanding this right. My book on IP networking is very old and dusty, so you'll have to bear with me. But the point is just that ports are not a concept when it comes to ICMP. ICMP only has codes and I believe the other term is types. And so let's see. Yes. Okay. So the so to whitelist ICMP, the protocol is ICMP or not IMP, and the security. And in this case, we're not doing a security group. We're just doing a whitelist of the internet block. And so we're going to just allow all inbound from all IP addresses on the internet over ICMP. And now the from port and to port, ports in this case are a misnomer. They're not actually ports. They're the mask of what types and codes you would like to have allowed through the firewall for ICMP packets. And so we want all of them. So we just do -1 according to the docs to grant all of them. Let me just make sure that's right. Yes, okay. So the start port or ICM type number protocol is ICMP or ICMPv6. So I think actually, let me just check this. So CloudFormation has different syntax here. So, I don't want to be misled by this. Let's see. So in CloudFormation, if you that's just whitelisting everything. In CloudFormation, you actually specify -1, -1 to allow all codes and types. I'm going to just do a little check though to make sure I'm doing the right thing. Let's see. What is this stuff here? Yes, I am in fact. Well, okay, so this seems to imply the same thing. Is this Charities? This is Charities' website. How funny. Yes, of course Charities written about this. Let's see. Okay. I apologize for reading live on the stream. I know that's bad. Okay. I don't think I'm going to be able to digest this. Let's see. If you want your host to be pingable, you have to put this stanza in your security group. From port 8 isn't in the docs. I found it in this issue. Okay. From port 8 to port 0. I would have never guessed that. If you want to create a security group following error, doesn't have a port. Okay, yes, I know it doesn't have a port. Let's see. Okay, see, look, Amazon is the same interface, and there's some documentation. From port is the number, the type number, and to port is the code, which does not exist. Right? Okay. Okay, that's just going to allow ping. I don't know if I want to not only allow ping, I want to allow all of it. Let's see. Okay, I don't really know. Oh, they have the docs. Okay, so maybe I misread the docs. Let's find out. So the start port or the type number. Okay, so I'm going to assume the type number probably starts at 0. Does that sound right? So I mean, when it says start, I'm going to assume it means starts at 0. To port is the end range port or the ICMP code. You know what? I have no idea what that 0 is for in Charity's example. So let's just read this one more time. Okay. Maybe I should carve out this. I don't really know. I mean, to port as 0 obviously seems to be the thing. The documentation is extremely bad though. Like the end range port or ICMP code, perhaps 0 is the ping ICMP code. Let's take a look. Oh yeah, that's why. Okay, so it's 0 is echo, and then that's ping. And then destination unreachable is what we want though, I think, at the very least, because my suspicion is that what's going on here is that the routers also care if you can't get to it over the internet. So we certainly want all the kind of traffic-oriented codes to be available. So let's say the to port is the end range port or the end range ICMP code. So I can at least determine that. Okay, so it looks like the range from 2 to 254 is a valid code, except the RFC one looks like an experiment. So let's just look here. You guys are learning as I learn. I just you know, on Amazon you can just say -1. But I guess, you know what I'll do here. This is another way to go about this. So ICMP frame. Let's just figure out how many bits are in that part of the frame. The code has 8 bits. Okay, so that makes it easy. So we know the maximum code is just 255. Okay, so basically that's the max code. The from code, I'm assuming they're just doing the same idea. The from is, oh, this is the type number. Okay, so the type number has a range of 0 to 8 bits, and this is the start. Wow, talk about a bad design. I don't really care. I mean, what you really want is you want to be able to specifically say, like either this specific type is allowed, not the start. Like certainly, anyway, this is just a bad design. I think CloudFormation handles this better. So I'm going to go on a limb and say the 2 port here, since it's the end of a range, it's wise to make it 255. So let's go ahead and now we can actually run this. So all I did was add the IMCP block here. And now if I go to my Terraform folder, let me just pull from master because I'm on a branch here. Let me just stash my Git. Okay, so pop it out of the stash. Again, just check my diff, that looks right. Okay, so then we have this shell script. We use a tool called TerraGrunt to actually run these things. I won't get into it here, but basically the TerraGrunt tool allows a little bit more of a sophisticated setup with Terraform. Now, one thing I'm going to do that is helpful perhaps to understand is, like I mentioned, we have on our Amazon, we have 2 clusters. We have our dev cluster and we have our production cluster. And so I mentioned earlier that the dev cluster is used when you're actually using a custom client on your computer, but the dev cluster also provides a lot of value in terms of staging these kinds of operational changes. It allows me to not have to just do it live. And so I'm going to actually apply this first to our dev cluster, which is a relatively low stakes change, and it allows me to really sanity check my work and make sure I didn't do something wrong. Now in this case, this whitelisting of ICMP, I think I actually could even further before I apply this. So this is actually just showing me what I'm about to do, right? So it's saying, okay, it's going to change the security group. Let's actually go ahead and just go one step further. So I'm going to go into a terminal here, and if I go to this Janus server, you can see this is a dev Janus server, suspicious Hobbit. Let's see if suspicious Hobbit is so suspicious that he will not reply to a ping message. So if I ping him, and he's on reticulum.io. Okay, so suspicious Hobbit resolves. You can see he has an IP address, but no ping, right? We cannot talk to him over ping, and this is bad. So let's go ahead and apply the change now. And now this is an open question, actually. I don't know if this ingress rule is going to allow ICMP in the other direction. TCP, you only need the one side. UDP, I believe you need both because it's a non-socket oriented protocol. ICMP, I'd assume, is the same. So let's find out. So yes, so it's not letting me ping it, even though I applied that rule. Now, I think I'm going to just, I'm going to go on a limb and actually add an egress rule as well, because I do think it would be nice if we could ping our servers. I don't think there's really any major risk to it. There are, I think, you know, there are actually, there may actually be some security risk to this. So I'm going to just go ahead and, just for the sake of my own understanding, just see if I can get ping opened. Oops. See if I can get ping opened. But I'm not going to actually apply it without doing more research. I don't want to do something that could be a mistake. But let's just try it really quickly in our dev cluster, because that's not a big deal. Just for my own understanding, because I want to see if these from port and to port rules are actually the right ones. And so this doesn't sufficiently prove that, but it does show that at least we get echo. So that looks good. You can actually see here. Here's our new ICMP rule, or egress rule. Or that's our, yeah, and then apply that. Okay, so now can I ping it? No, I cannot. Okay, So let's see. If I go to my security groups now, I may need to reload this. So let's see. If I go to my suspicious hobbit, let's take a look. Is he hiding still, or so outbound? Let's do inbound first. All right, so here's my ICMP rule. Hilariously, this still says ports, which is not helpful. And hilariously, it also doesn't even tell me the other one, the to port, or the from port rather, port, quote unquote. Okay, so at least that rule looks there. And then if I look at the inbound rules, similarly, I should expect to see that. Okay, 255. Now, I already said that we don't use the console because we don't want to, inadvertently change things and lose track of the fact we changed them. However, the console can be a useful tool when it comes to actually understanding what the heck are the right ways to configure these things. And so I'm going to go ahead and I'll go to another one, like we have this Bastion one. I'm not going to make any changes here. Well, I will temporarily. I'll roll them back. This is mostly me going to dev and just messing around a little bit. So let's see. If I go to the inbound rules and I change this to ICMP, let's take a look if this gives me a hint as to this. So, all right, port range is all. Source and description. Here's an idea. I mean, what I'm basically trying to do here is tease out the quite poor interface that Terraform has given me and make sure I actually understand what is going on. So if I, let's go to the stream one that actually was changed. And let's see if the Amazon UI gives me a hint as to what could be going on. So let's see, dev stream, inbound, outbound. Wait, hold on. Dev stream. Did I apply this to the wrong one? Is that the problem? Oh, sorry, this is not the right, it's not stream, it's Janus. Stream is a Hub's Cloud thing. All right, so here we go, dev Janus. Okay, so now, so this is interesting, right? So the protocol here is echo reply, and the port range is 255. Okay, so that implies to me that the protocol here, since it explicitly said echo reply, this is in the outbound rules, this is the egress. For whatever reason, it's not saying all ICMP, it's saying just specifically that protocol. Let me just, I'm gonna just see what happens if I change this to 0, 0, and see if that gets the UI to say it's all. So let's apply that really quick. I mean, this is quite a hacky way to understand what's going on, but it is a sufficient way to do so because I'm trying to understand the mismatch between this really crappy interface that Terraform's providing me, which obviously is very confusing because there's an entire blog post by Charity about it. And the good news is that the AWS console actually will tell me stuff that's useful. So now with this 0, 0, it's still assuming the protocol was echo reply. Just as a sanity check, let me just go make sure I understand what the rule will look like in the UI if I were to do it with the UI end to end. And again, I'm going to break my one rule here. I will quickly revert the change, but in this case, I'm using this as a means to an end to get a better understanding of the nature of how these things are configured. So if I go and I just turn on the all ICMP traffic, let's do that. That looks good. All right, let's do that. Okay, so now, yes, you can see protocol here and port range is all, right? Okay, now I'm gonna do a little trick that can also help tease this out. This is not where I expected to go with this stream, so I hope it's interesting. So I went ahead now and I just manually overrode a firewall rule in Amazon. And of course, like I mentioned, we're keeping track of all of these in our Terraform. So Terraform is going to complain about this if I try to run it. And so I'm going to go ahead. I'm not going to apply anything. But this is going to give me the last clue I think I need to actually understand what the proper setting is here. So to summarize, I went to Amazon. I actually configured it manually because I don't know the right Terraform for this because the documentation is weird. There are bugs. I don't really know what the right thing to write in Terraform is. This is actually fairly rare, but here we are. And so the trick I'm going to do is do the thing I want it to be on Amazon, and then run Terraform, and Terraform is going to take a diff. And look, it did notice there's a problem, right? There's a mismatch between what is actually in Amazon and what is in my file. So now, in this case, the stuff on Amazon is actually what I want. And this is telling me what Terraform would like to change it to. Now, this rule is not in the Terraform. So the right side of this should reflect what the rule would look like without it being there. And the left side should reflect what is live on Amazon. And I think this gives us the clue we want. So you can see the from port is -1 and the to port is -1. Now that was my original guess, but whenever you're doing this kind of thing, you really want to get to a point where you grok as much as you can what is going on. And of course we have a lot of layers, right? We have the dev infrastructure, all of that is there. We have Terraform watching our back. So there's a lot of kind of safety nets. So there was no risk at any point during this that I would break hubs.mozilla.com. I've been working completely in a sandbox. So I'm going to go back to my AWS console, and I'm going to just now remove that little rule I added, and now save it. And now as the sanity check, I'm going to go and I'm going to rerun my Terraform on the security group that is related to. And now Terraform should say everything looks good. Nothing is off base. Everything is exactly how it should be. And it didn't, so let's see why. Okay, so it's saying that, that's interesting. Let's see, Bastion main. Interesting, so okay, so now Terraform is saying that there's an egress rule in Amazon, or in the file that's not on Amazon, which is very strange. I don't know what that's about. This may literally be drift that occurred between the file and the Bastion. I'm going to just run this against I'm really getting off the track here, but I'm going to just do this really quick. So I'm going to run this. I'm not going to actually execute it. I'm going to just sanity check it against our production cluster to see if dev is just out of date on this particular security group I just mucked around with. Really quick. It looks like it's downloading something. This is what we call a yak shaving for anyone watching. Okay, so this is interesting. So I actually discovered something along the way here that is not a problem, but interesting and probably should be resolved. So we have an egress rule in our Terraform that was applied to the production site, but not to the dev site. So I'm going to go ahead and apply it since it's already in prod, and I don't really remember what it's about. It's an egress rule letting the Bastion talk out over the internet. Let me just take a look. Let's see if so I'm going to do a git blame on what is this, Terraform modules. Oops, git blame modules Bastion main. I also want to actually get to the end of this. So let's see, it was on line 25. This was a commit by me. Let's see what this commit was about. So this is a good way to understand why things are the way they are. Okay, very bad commit message, shame on me. This looks like it was to help with Habitat, probably some kind of orchestration issue with Habitat. So it was by me, and so I'm going to just apply it in dev. Dev is low stakes, and we're already doing this in prod. Okay, so now that I'm now that I'm finally off the sidetrack here. Yeah, I mean, we all do this. I'm just trying to be very careful, and Murphy's Law is in full effect, by the way, because I'm streaming my face on the internet. So, okay, so back to up the layer of the stack. So we now know what we actually need to write in here, which was what I kind of suspected is -1 to -1. And let's go back. So if you recall, we had our egress rule and our ingress rule. And the ingress rule is the only one I'm going to keep because that's the only one that we were reported as having to need to have to resolve this problem by people in our Discord. And so it's the only rule I'm comfortable adding right now without further research. But I would like to verify that these are letting me ping. So, okay, so now I'm going to apply it to Janus in dev. And now we should see that it's going to now want to change the port range, port in this case meaning code and type range, -1 to 1, -1, -1. Okay, this is really long because there are all these other rules that are not changing. But it all gets rolled under the same security group. Okay, so now if I ping this guy, ta-da! So now we can talk to him over ICMP. So now I don't want to keep this egress rule. So let's get rid of that. Oops. Yeah, so let's get rid of this. And then, I'll say we'll get rid of this. I'm curious I'll be able to ping still. My bet is I won't be able to, but this is at a level of the IP stack that I don't really have my head around. Oh, I guess we can. Okay, so fair enough. Apparently you don't need the whitelist for the egress for when it comes to ICMP for the round trip response. I'm sure people that know more about IP networking will have a better understanding of why that's the case. And so the last thing I'm going to check before we go to production is that this reflects correctly what I expect it to in the console. So basically, if we go here, we now should have one new egress rule, all ICMP. Excellent. Oh, and I forgot to mention, I'm going to add also ICMP 6 as well for people that are using IP6. So I think the syntax there is yeah, ICMP v6. Okay, so let's add that. Go ahead and apply this. I don't actually know how to do whatever the equivalent to a ping is over IPv6, but maybe if someone in the chat knows that, they can tell me. Okay, so about 10 minutes to go here. I think we'll actually at least get this part done. Okay, so there's full IPv4. This is full IPv6. Looks like Amazon has a bug here and it should say all, but the protocol and port range is correct. So, oh, maybe because it's IPv6, it's considered custom for whatever reason. All right, so that looks good. As one last sanity check, let's just make sure Hubs actually works in dev as a last, check. And now this is now going to connect to Janus with those new firewall rules in place. And that is looking pretty good. Yep, here we are. I can verify that we're connected properly. If I go to About WebRTC, I can pop open my peer connection information. You can see I connected over a UDP-based peer connection. All the other candidates are there, but this is the one that the WebRTC stack chose. So there were no connectivity issues, at least for me, due to this change. And so that makes me feel relatively comfortable going forward with it. So I'm going to go ahead and just apply it to production. And hopefully after this, that means a good number of people will start to be able to connect to hubs that normally wouldn't have been able to, which is exciting. Okay, so let's just look at this. Let's make sure. So it's only changing this. Now there are two new ingress rules. That makes sense. By the way, you'll note I'm going to be a little bit more careful here because this is now affecting production infrastructure. You can see this is my first new ingress rule for ICMP. And all of these are the same, all of these are the same. This is all the same stuff. Looks right, looks right. Okay, and here's our new rule for ICMPv6, -1 to -1. And let's just say yes, and now we're doing it live. And now if I go to my security groups, and I go to dev prod Janus, one thing I didn't do in this case, which is a big mistake on my part, is I didn't announce to our Slack channel that I was doing this, in part because this is a relatively low risk change, if I'm being honest, and also I don't want to pull up any potential Mozilla confidential information in the stream. So if I go to the Janus security group, and I'll just double check this applied the way I wanted, yes and yes. and just make sure I didn't accidentally keep that egress. Nope, nothing there in egress. So looks like the change has been applied. So let me just make sure before I commit this to the repository that Hubs is still up and happy. Looking good. And I'll check my WebRTC as well. So here we go. It's looking good. Pop this full screen for anyone watching. And now here's my candidates, same thing. Everything looks good. And I think that change is now done. And so I'm going to go ahead and just commit it. So sanity check my change, and make a nice commit message. Hopefully one that won't be as embarrassing as the one I pulled up before diagnosing the other thing. Ingress rules to reduce risk of UDP disconnect. Okay, cool. So now if I go ahead and, by the way, doing a live stream is a great way to improve the quality of your commit messages. Okay, so, okay, and this is a branch I'm working on, but I'll land this after the stream is over. This is a branch of this Janus rollout I'm working on, which is imminent, so I'll just keep it on this branch for now. And so that's basically the end of that. So I don't think I have enough time to cover the other things I had. So I was going to try to talk about Turn a bit more. I guess I have about 5 minutes, so I can give a really brief demo of that, unless there's any questions in the chat that I can answer. And if there are questions, I'm happy to go a bit over the end of time for anyone who's watching. So I'll jump into Turn. So as I mentioned, Turn is an additional layer that we've added that allows you to bypass some certain kinds of firewall conditions. And it does that by speaking over a fixed port instead of over a range of ports. Now, there's a lot more to Turn than that, but that's what we're using it for. It's used for other reasons in different contexts. But we're using it exclusively as a way to provide a fixed port that people can be sure to be able to connect to and have WebRTC work. And so if you recall from when I was looking at, or if you caught it, when I was looking at this WebRTC debugger, so this is in Firefox, and this WebRTC debugger allows you to get a sense of what the WebRTC stack is doing in the browser. And in this case, WebRTC, when it starts up, creates what are called a list of candidates. And these candidates are effectively the IP and port endpoints that WebRTC is going to take a shot at trying to use to communicate, in this case, with our server, our Janus server. And so you can see that it actually selected a whole bunch of candidates. These are all potential ways it could connect. And then ultimately it decided upon this very first one, right? And so there's a lot of different things that I could talk about here. I mean, generally speaking, you can see that it's talking over UDP, like it's a UDP based connection. That's what you want. It's also over a really random port. So that implies that it's not using Turn, because as I mentioned, Turn is only going to speak over 443 or 80. We can actually be positive that it's not using Turn because this candidate is labeled as SRFLX, which is it's a reflexive candidate. I forget the exact terminology for these. I'm not a WebRTC person, but there's two kinds of reflexive candidates that it'll grab. And the way you know it's using Turn is if it's using what they call a relay candidate, because Turn acts as a relay. Yes, so in regards to why are we using Terraform, CloudFormation, and Custom Tool, well, the reason is, well, when we started with Hubs, we were just running it on Mozilla's infrastructure on AWS. And so we started with Terraform since that was basically the right tool for the job. It's kind of the standard, or one of the standard ones to use. And now, but then we started to work on Hubs Cloud. And so with Hubs Cloud, we really wanted to run it in AWS Marketplace. And AWS Marketplace, the only way to do it is to use CloudFormation. There's no path to using Terraform to stand up infrastructure on CloudFormation. So yes, we were actually forced to implement all the stuff in CloudFormation, despite if we had the choice, probably would have preferred Terraform. But that said, the definition of Hubs Cloud on Amazon is actually turns out to be quite different than hubsmozilla.com. For example, I mentioned we have blue-green deploys for hubs.mozilla.com. We don't have an analog of that in Hubs Cloud. And a lot of the resources we do in Hubs Cloud are different. For example, we use a a different RDS type of database. We use elastic file storage, or sorry, we do actually use file storage like this on the main thing. And then we also run servers in a slightly different way on Hubs Cloud. Because we wanted Hubs Cloud to be possible to run a single server, we actually have scenarios where you jam all the services, including Janus, onto one box. And so we don't have that analog in our hubsmozilla.com infrastructure because we always run Janus on a separate machine than the other services. And so it ended up being quite a distinct setup. And so in that sense, there's less duplication to a degree because there are actual differences. However, there's a lot of redundancy nonetheless between the Terraform scripts and the CloudFormation stack. Now, with regards to why did we not use that for DigitalOcean? Well, in DigitalOcean's case, we're listed in the DigitalOcean marketplace, and sure. And in that case, it's a similar kind of constraint. There's no way to run Terraform or CloudFormation for obvious reasons when you're listed in the DigitalOcean marketplace. Now, one fortunate thing is the amount of effort we need to do to set up things on DigitalOcean is quite less because it's a very constrained deployment target. We don't have the ability for you to run multiple servers. We don't have elastic files storage. We don't have like all that. We just need to set up your database, get your firewall configured right, and if it can, configure your DNS. And we don't set up CDN. We don't set up SSL in terms of a CDN SSL cert. Like there's a lot of stuff we do on Amazon. We don't set up your email. So all that is kind of up to you to do on DigitalOcean. And so because of the less amount of work needed to be done, it was tractable for us to just hack out a shell or node script to deal with that. And so that's why we have 3 distinct things. There is some duplication and it's unfortunate. And insofar as we're able to dry it up, we will. But the sad part is that these are just such distinct tools that there's really not a whole lot of room for kind of extracting common functionality. So, but anyhow, that's about the end of the stream. So I hope this was interesting. It was a little bit roundabout, but I kind of expect that's how these things will go. And so it was fun to be able to deploy something to production live on the internet. And hopefully, there was something interesting to get out of it. I know I learned some stuff. I'm not ashamed to admit when I don't know what I'm doing until I kind of do a little more research. So that's kind of how I go about things. And so if anyone was watching and sees that I did something that was potentially bad, I would love feedback on it. And I'm obviously trying to be very careful. So so thanks again, everybody. And I'll be trying to do this again twice a week, Tuesdays and Thursdays. So be sure to check it out next Tuesday at 4 o'clock. Cool. Oh, and Bob, to answer your question, we've talked about if we might want to move our infrastructure to the Hubs Cloud setup. However, the blue-green deploys for us are pretty critical. It's a very important tool for us to ensure uptime of the Mozilla service. And so including that kind of deployment process was out of scope for Hubs Cloud. Since it is fairly involved and does require running multiple servers, which would increase costs. So we didn't include it, but it does mean that we're kind of blocked from migrating to that. Now, certainly we could get closer to Hubs Cloud by abandoning Terraform and migrating our infrastructure to CloudFormation, and then maybe perhaps we could extract common functionality from our CloudFormation template for Hubs Cloud into a unified framework so that there'd be one representation of these things. But that's a big project and it's not something we started to work on at all yet. So hopefully that helps. All right, thanks everybody. Signing off. See you next time.